Even with many of the techniques discovered to make the learning parallelizable, very deep networks are still very hard to train end-to-end, from input to output in one go. Not only is it slow and costly, but often the training gets stuck. No appreciable gain is made. So it's natural to want to train in a few layers at a time, followed perhaps by some end-to-end retraining to refine. To some extent, the previous subsection presents one idea along these lines. Take the earlier layers from some previously trained network for some related but different task. Autoencoders take a different idea. Suppose we consider 3 layers. Let's make the middle layer smaller than the input and output layers for this small network. So in effect, the data has to flow through a bottleneck and will be necessarily reduced in some information sense. Now, suppose we train the network to reproduce its input as well as it can. Because of the bottleneck, it must throw away some of the input information. But since it is tasked with reproducing the input for the set of training data as best it can, it must end up choosing to keep the important features, i.e. the important information, to throw away the less important information, perhaps noise, perhaps irrelevant detail. This is the basic idea. The method effectively learns empirically what is the important common information in the training data. It's a sort of empirical dimension reduction process. We met LDA and PCA before. It's a kind of generalization of these. After training the 3 layers, you throw away the last layer. It was only there to force the reconstruction. You now have layers that do the information preserving and coding. You can then train the next autoencoder with the output of this, each layer on layer being built with autoencoder training. In such a way, you can train a very deep network a few layers at a time.